Alrighty, let's take a look at this question. So it says find the exact sum of the positive roots of that quadratic equation and this quadratic equation. There's a fair bit going on here. So first of all, when they say the word roots and they give you an equation, what they're asking for is the solutions. That basically means the solutions as in what is x equal to, right? Now, normally with a quadratic equation, you would try to factor it first to find the solutions or to find the roots. But we would not be able to find anything that multiplies to -2 and also adds to -2, because -2 could only be 1 times 2, and if the signs are opposite, they would not add to the middle term of -2. They would add to, well, 1 or -1. So factoring this is not how we're going to be able to solve this. We are going to have to use quadratic formula to solve it. So quadratic formula is x equals -b plus or minus the root of b squared minus 4ac all over top of 2a, where a would equal the coefficient of x squared, so a is 1. B would be the coefficient of x, so -2. And c would be the constant term, which is -2 as well. All right, so we are going to sub that in and get an expression for our roots. So we have -b, but b is also -2, so it's like -2, which would just be +2. I'm just going to write +2 for that. So 2 plus or minus, and then b squared. I know when I square something, it's just going to become positive, so I'm just going to write 2 squared minus 4 times a, which is 1, c, which is -2, all over top of 2 times a is 1. All right, we're going to simplify what's underneath the radical first. So 2 squared is 4, and then -4 times 1 times -2 would be +8. So 4 plus 8 is 12, or you can really just put it in the calculator if you want, the thing under the square root. Okay, that's all over top of 2. Now this is where radicals come in, okay? We want to simplify that radical of square root of 12, so we want to write that as a mixed radical. So we are going to break that down into a perfect square. Root 4 times root 3 would give you root 12, and the square root of 4 would be 2, so 2 root 3 that becomes. And then, because 2 is a common factor of everything, we could divide 2 into all 3 of those. Now, when you divide 2 in, remember 2 divided by 2 is not 0, it's 1. So we want to write a 1 plus or minus 1 root 3, or we could just write root 3 there. Now, it says the exact sum of the positive roots. One of these roots is 1 plus root 3. The other one is 1 minus root 3. They only want the positive root, and I'm pretty sure 1 minus root 3 would give you a negative number. So this would be the positive root from that particular quadratic equation. So you're probably thinking right about now, wow, this question's huge, and you are right, because we still need to find the positive roots for the other equation. So I am going to work that out and do that here, and then I'm going to resume the video. So I'm just going to pause that and then figure out the answer for the second equation. Same idea though, you use quadratic equation or quadratic formula. Okay. Alrighty, so I worked out those two answers and I got two answers, -1 plus 2 root 3 and -1 minus 2 root 3. Because they only want the positive root, we're going to use only the -1 plus 2 root 3. How do we know that's positive root? Just simply put it in the calculator. Go -1 plus 2 times the square root of 3. That'll be a positive number, but the other one's going to be negative, so we don't want that one. All right, now back to the question. That was a lot of work. Find the exact sum. The word sum in math basically means adding. So we are going to take the first one we had, 1 plus root 3, and we're going to add the second answer we got, -1 plus 2 root 3. and that would be the exact sum. We still have to simplify it, but that would be our sum. All right, now we can only add and subtract like terms. So first we've got a number 1. Oh, and we've got another one, -1. Look at that. Those two will just equal 0, so that's gone. And then √3 plus 2 √3, when you add radicals, you add the coefficients, as long as the radicands are the same, which they are, they're both 3. So we would add the coefficient of 1 √3 plus 2 √3 would be 3 √3. And that would be your final answer, the sum of the positive roots of those two quadratic equations. Whew, that was a lot of work. All right, there we go. I hope that helped.